Right now your phone is having thousands of conversations you'll never hear. It's talking to cell towers, GPS satellites, Bluetooth devices, and Wi-Fi routers, all simultaneously, and every conversation is happening in code. These aren't random signals, they're protocols, hidden languages that devices use to coordinate in milliseconds, and without them, your phone would be a useless brick. Here's what's wild. When you make a call, your phone doesn't just connect to a tower, it negotiates. It says, "Hey, I want to connect." And the tower says, "Prove who you are." Your phone sends encrypted credentials. The tower verifies them against a database. Both sides agree on encryption methods. Then, and only then, does the call connect. This happens in under 1 second, and you never see it. Let me show you how deep this goes. Your phone is constantly searching for the strongest signal. It measures signal strength from multiple towers, compares them, and switches between them seamlessly as you move. This is called handoff, and it's happening even when you're standing still. But here's the insane part. Towers have limited capacity. Each tower can only handle a certain number of connections. So your phone and the tower negotiate not just connection, but priority. Emergency calls get highest priority. Then, active calls. Then, data connections. Then, idle devices. The system is constantly ranking and re-ranking every device based on what it's doing. And the data transmission? It's not continuous. It's split into tiny packets, pieces of information, sent separately sometimes through different routes, and reassembled at the destination. When you stream a video, your phone isn't downloading one file. It's receiving thousands of packets from different servers, possibly on different continents, and stitching them together in real time. If packets arrive out of order, the phone resequences them. If packets are lost, it requests retransmission. This is TCP/IP, Transmission Control Protocol, Internet Protocol, the foundational language of the Internet. Now here's where it gets truly insane. Error correction. Wireless signals are messy. Interference, obstacles, distance, all of these corrupt data. So protocols include redundancy. They send extra information specifically designed to detect and fix errors. There's something called a checksum, a mathematical value calculated from the data. The receiver recalculates it and compares. If they don't match, the data is corrupted, and a retransmission is requested. More advanced protocols use forward error correction. They send redundant data that allows the receiver to reconstruct corrupted bits without asking for retransmission. And the efficiency is wild. Modern protocols can transmit data with 99.99% accuracy, even with 10-20% packet loss. But there are hidden layers. Your phone doesn't just use one protocol, it uses dozens simultaneously. There's LTE for cellular data, Wi-Fi for local networks, Bluetooth for short-range connections, NFC for contactless payments, GPS for location. Each protocol has its own frequency, power level, and data encoding method, and they're all coordinated by your phone's operating system, which is constantly deciding which protocol to use for what. Send a text? Use cellular. Stream music at home? Use Wi-Fi. Transfer a file to your laptop? Use Bluetooth. But the system is also adversarial. Protocols are designed to prevent hacking, spoofing, and eavesdropping. When you connect to Wi-Fi, your phone and router exchange encryption keys using a process called handshake. These keys are unique to this session and change every time you reconnect. Even if someone intercepts your data, they can't decrypt it without the key. And then there's 5G, which is less a new protocol and more an entire ecosystem of protocols. It includes network slicing, where the same physical infrastructure creates multiple virtual networks. One slice for your video call, another for autonomous vehicles, another for industrial sensors. Each slice has different speed, latency, and reliability guarantees. Here's the real power of this system: standardization. Your iPhone can talk to an Android, your laptop can connect to any Wi-Fi router, your car can pair with any Bluetooth speaker, This only works because companies agreed on shared protocols, but standardization is also a battlefield. Competing companies fight over which protocols become standard because standards equal market control. Qualcomm holds thousands of patents on cellular protocols and charges licensing fees to every phone manufacturer. So, what's the lesson? Devices don't just work, they follow protocols, negotiated languages that allow them to coordinate, correct errors, and maintain security. And the more wireless devices we have, the more complex the protocol negotiations become. Next time your phone connects to Wi-Fi or makes a call, remember, it just negotiated a connection, exchanged encryption keys, and started transmitting data in coordinated packets, all in under a second. That's not magic. That's the secret language that runs your phone.